Good day guys, you are welcome back to my YouTube channel. So on today's video I'm going to be talking about chain rule under the introduction to calculus, that is under differential calculus. So what is it about chain rule? First of all, for us to apply chain rule, there has to be a particular situation for us to be able to apply chain rule. For example, we are given something like y is equals to 2x plus 3 all square. Somewhere like this is where we apply chain rule. Or if we are given something like y is equals to sine 2x plus something like 2x plus x square, somewhere like this is where we apply chain rule. The place whereby there is a function inside that function, that is where y is equals to the function of x, if you understand about functions. So let me take this number one here. Number one here, we have y is equals to 2x plus 3 square. Now if we want to differentiate this using normal method, we first have to expand this bracket, then we do our normal differentiation. That is, from here we can do 2x plus 3 times 2x plus 3 squared. This is normal method. We have 2x times 2x, we have 4x squared plus 2x times 3, that is plus 6x, plus 3 times 2x plus 6x, then 3 times 3 plus 9. Then we have simplify as 4x squared plus 12x plus 9 as our y. Then we get the y dx as, when we differentiate this according to our former video, we have 8x plus 12 as our final answer. But what if we are going to use chain rule? If we are to use chain rule, that means you need to know the formula for chain rule. The formula for chain rule is dy dx is equals to dy du times du dx, whereby we pick one of the function as u. So for example, in this question here, we have y is equals to 2x squared, right? So that means we are going to make 2x squared 2x plus 3. 2x squared is another function inside the whole function, which is this square. So we can make 2x plus 3 equals to u. So we have y, so we have u is equals to 2x plus 3. We pick this one inside bracket here and make it u. So that means u is equals to 2x plus 3. Then we find for du dx, that is differentiation of u with respect to x. So we have du dx will be equals to, when we differentiate this, we will have 1 times 2x raised power, we have 2 as our du dx. So this is our du dx. Then that means if u is equals to 2x plus 3, that means y is equals to, now we have already mentioned that u is equals to 2x plus 3. So we have our u, because u is equals to 2x plus 3, it will now be u squared. So from here we can find for our dy du, that is differentiation of y with respect to u. We have dy du is equals to, when we differentiate this, we have 2u raised power 1 as our differentiation. Then after we have gotten our dy du and we have gotten our du dx. So what we have to do is to apply this formula here. We'll get it as dy dx is equals to, dy du is 2u, that is 2u, then times, what is our du dx? Our du dx is equals to 2, so we have times 2. So then when we simplify this, we have 2 times 2u, that is equals to 4u. Now we go back to this place where we have our u is equals to 2x plus 3. So we bring back our u here as 2x plus 3. We have it as 4 open brackets 2x plus 3. Then when we simplify it, 4 times 2x, we have 8x. Then 4 times 3, we have 12. So our final answer is equals to 12 using the chain rule. You will notice that using the chain rule and when you expand it normally, we got the same answer. But what if we are now given something that we cannot easily expand? There's some kind of expansions where we have to use binomial theorem to get an answer. You just have to simply use chain rule so that you get your answer directly. So now moving on to this question here, this question 2, where y is equals to sine 2x plus x squared. So using the same way, we are going to pick the function inside the main function. Now the main function is sine this here. So that means inside this is another function here. So that means we can pick our u as this. We have u is equals to 2x plus x squared. So from here we can get du dx. Du dx will be equals to, the differential of this will give us 2, then this will give us plus 2x raised to power 1, which is the same thing as 2x. So this is du dx, and that means for us to bring back this equation, we have y is equals to sine, where we have already gotten that u is equals to 2x plus x squared. We just put u there, we have sine u. So from here we can get our dy du as, now differentiation of sine u is equals to cos u according to the trigonometric law. So dy dux is equals to cos u. Then we can apply our chain rule formula. We can put it as dy dx is equals to dy du. This is dy du. Our dy du, which is cos u, times du dx, which is equals to 2 plus 2x. So from here we can bring back our u here as 2x plus x squared. Then we have it as dy dx is equals to cos open bracket 2x plus x squared times 2 plus 2x here. Then we can bring it to the back here and we have our final answer as dy dx is equals to 2 plus 2x in brackets times cos 2x plus x squared, those brackets. So this is the final answer for using this, doing chain rule. Now you notice that something like this, you cannot use another method except chain rule. That is why there is chain rule. That is the importance of chain rule.